Hey guys, cool, welcome back. First thing is we're actually taking attendance now of these lectures, so I need you all to type your names so I know who's here. So I've got I got Caleb ticked off. I can't remember who anyone else's usernames are though. So please type your names so I can remember who's who. Alex, cool, cheers. Just your first names will do. We don't want to have a GDPR issue. Joan, hey Joan. Sophie, hey Sophie. Anybody else? How many of you are in? How many we got? 9. I've got 5 of you, so still missing. Well, Tom will be one, so still missing 3 of you. Roddy, hey Roddy. Anybody else? No, maybe not. 6, 7. Still should be 2 more. Oh well, cool. All right, so we're gonna start where we left off um last Thursday. Where's Lucas? Do you know, was Lucas meant to be here? Was he gonna watch this as well? Don't know. Anyway, so we are doing mechanics revision and we are finishing off Suvat. So yeah, a few more Suvat questions. So I think the main ones are velocity time graphs, and then we're going to go back to projectiles, and hopefully in a couple of weeks' time we'll have done all of mechanics again, and then we can get onto some pure stuff. All right, so if you guys could try this one, it's 6 marks, so I'm going to give you guys 6 minutes, and then we will go through it. Cool. If anybody else does turn up, I will tick you guys off on the register as and when you do. Cool. Right, give it a go. 6 minutes. Good luck. Oh, and ask if you need help and comment your answers when you're done. Anybody need any help? Cool, yeah, Callum have ticked you off as well. Good. So remember to comment your answers as soon as you've got them. We'll be going through this in about 4 more minutes. Yep, that is correct for you. Well done. Is that Joe in there? Well done, Joan. See if you can find the acceleration as well. Nice. Well done, Joan. And yeah, brilliant. Cool. Right, rest of you got 2 minutes to finish it off, and then we will go through this. Oh yeah, it's because yeah, exactly. I worked out my air horns and intro last week, so yeah, thought we might as well keep going. I know everyone else is starting on Wednesday, but I thought keep going. I mean, we started on Thursday technically, so yeah, for the joy of teaching. Yeah, you got it. So Charlie, I'm gonna mark you as late because you didn't comment your name yet on my register. Cool. All right, time's up. All right, let's go through this then. U does equal 10 over 3. Well done. All right, so we know the total area equals 100. Yeah, that sounds good. So area equals 100. And we know the area is going to be a trapezium plus a rectangle plus a triangle. I mean, I guess you could do it with two trapeziums looking at this now, but when I did it earlier, I did it like this for some reason. Um, so I'm going to work out all these different areas. So we got half of u plus through 10 times 3 plus half of 7 plus 9 times 10, which I think should work as well. So I'm actually going to do 2 trapezia. Yep, that'll work nicely. That's right. Cool. I didn't do a register back then anyway. So if we work this out, we're going to set this equal to 100. And if you solve through that, you can get u equals 10 over 3 meters per second. Nice and straightforward. Cool. All right, second one, find the acceleration in the first 3 seconds. So that's basically asking us to look at the gradient. So part B, gradient equals acceleration. And so we can do, well, rise in y divided by rise in x. So 10, take 10 over 3, divided by 3 equals the acceleration, and you get a is 2.2. meters per second squared. Cool. Anyone got any questions about either of those bits? Should be pretty straightforward. I think we've got about 2 second lag, so I'll wait a couple more seconds and then we'll move on. Cool. All right, so next one. So here we've got a nice horizontal Suvat question. So particles moving straight line with constant acceleration, A, B, and C lie on the line. Particle moves from A through B to C. So we've got A, B, C. Yeah, can you guys try and find the acceleration and the time taken and the distance? So this is 7 marks. I'll give you guys 7 minutes exactly to try this one. And again, the first person to comment is the best. So try and comment the correct answer first. Cheers, guys. Time is 16, is it really? Let's have a look. Yes, I agree. What's our distance though? Two, three, four. That sounds good to me, Alex. Alright, you still got 4 minutes, so if you're done, brilliant. If you're not done, keep going. If you are finished, you can well, I can't really set you any more work because that would ruin the slide for everybody else. So if you do want to race ahead, here's a sneak peek of the next one. If you want to screenshot that, I guess you could start working on the next question. But I'm going to go back now to the other slide. So screenshot now if you want it, and back. So still got 3 minutes 30 left. Anyone need any help? Please comment if you need any tips. It's good, Roddy. What were you on before on your phone? I imagine that would be quite difficult. All right. So let's go through this. So we want to try and find the acceleration of the particle. Um, cool. So, all right. Where are we at? Cool. So yeah, it goes from A through B to C. And we know our initial velocity is 2. So let's make a list of all these bits. U equals 2. V equals 7. Final velocity. So we're looking basically at the region from A to B at the moment. And T is 20. So we can say for part A, V equals U plus AT. 7 is 2 plus A lots of 20. So 5 equals 20 A. So A equals 1/4 or 0.25 meters per second squared. Cool. All right. Part B is they tell us the velocity at C is 11. So we've gone from 7 to 11. We know the acceleration. We want to try and find the time now. So now we're looking at this region. U is 7. V is 11. A is 0.25. So we're going to use V equals U plus AT again. T's are unknown. And we get 11 equals 7 plus 0.25t. And we can solve that to get t is 16. Last bit, distance between A and C. Well, we know the overall time is going to be 16 plus 20. So overall time is 36. We know the acceleration. We know the initial speed was 2. A is still 0.25. So you can S equals ut plus alpha at squared. And we get S is 2, 3, 4 meters. Cool. Should be relatively simple. Just some linear Suvat. Okay, next one. Slightly more difficult. We've now got particles meeting, so we need two different expressions. So again, let's have. You guys are doing this pretty quickly. I'm going to give you less time this time. I think we'll say 7 minutes. So 7 minutes on the timer. And give it a go. Remember, comment if you need help. Okay, why are you guys confused? What's the problem? So, for this one, what you want to do is come up with two expressions for each particle. So P is, we're doing it in terms of T. And in terms of T, Caleb, I'll block you if your chat isn't more decent. So yeah, sort yourself out. Um, yeah. So particle P is the one we're kind of doing it in terms of. So T is the times after P has passed through A. So come up with an expression for particle P. For particle S, we need to try and relate S to have the same letter T in it. So we need to try and link the two together, thinking about what the expression will have to be for T for particle S's equation. So if you think, say that particle P has been moving for 5 seconds, how long has particle S been moving for? Have a think, and then try and work that into your equation for the two displacements, and then solve those two simultaneously. Cool. Give it a go. I'll give you another minute on the timer. So I'll give you another 4 minutes because it is quite hard, this one. Um, see how you get on. So it's Joan. I don't think those are right, Joan. Should be. I think it should be exactly 6. Yeah, time should be 6 and displacement should be 6d. So have another look through. Something's gone wrong. Check your signs, Caleb. You got the right idea, but why are you subtracting your acceleration when it's moving sideways and accelerating? Cool. Right, time's up, guys. So let's have a look. So I think you'll struggle a bit more with this one, which is good. We want to find things that you find difficult and try and improve those things. So we're going to come up with two expressions, one for P and one for Q. So for P, I'm going to use S equals, so if I read through quickly, P has that acceleration, P has that speed. That's all I need. So S equals 40 plus half AT squared. It's going to be half of 2t squared. And for Q, this is where it's a bit more difficult. There's Q's acceleration, there's Q's speed. The only problem is it says 1 second later. So S is fine. We can still use S. U is going to be 3. Then we've got the problem with T plus half AT squared. Problem is, what do we use for T? So if P takes 5 seconds to get anywhere, how long is Q going to be moving for to get to the same place? Well, P's gone. Second later, Q moves. Q's only going to do the same distance in 4 seconds. So it's going to have 1 second less than P did. So we need to call it 3 lots of T minus 1 plus 3.6 lots of T minus 1 squared. Yes, it is, Charlie. Well done. Is everyone okay with that, though? Why it's T minus 1? If the journey takes this one 5 seconds, they get there at the same time, this one's going to have to only be moving for 4 seconds, for example. So we need to do T take 1. Okay, so that's part A done. All we need to do is solve these simultaneously. So we're going to say 4t plus t squared equals 3t take 3 plus 1.8 t squared minus 3.6 3.6 t plus 1.8 respectively it is. And then if we solve those, we get t equals 6. Cool. And then for part C, find the distance of A from the point where they meet. Well, we're just going to put, I don't get why that's 3 marks. That seems a bit crazy. Yeah, put 6 back into there, and we get S equals 60 meters. Weird. Don't know why it takes 3 marks for that, but there you go. Cool. Anyone got any questions about this one? Oh, hang on a minute. Maybe distance of A from where they meet. We know the displacement would be 60. Distance of A. Let's just check that. So, expressions for the displacement. Got it. We found the overall displacement, but we might not have found. Yeah, okay. I think that's actually wrong for that bit. I think we need to do an integral here. I think. Let's find out. So if we plot, let's bring up the calculator and let's try and plot that expression for our velocity. So let's go to graph and delete what I was doing earlier. Cool. Right, so I'm going to plot y equals 4t plus t squared. Cool. Draw it. And let's sort these axes out. So view window, standard. Still not great. We can probably stretch those out. So if we go from 0 on the x-axis to 6, this is what we're really interested in. Oh, okay. And on the y-axis, let's go up to 60. It looks like it is going to be right after all. So exit, sketch it. Yeah, okay, fair enough. So its displacement will be 60 and its distance will be 60. But it's a good thing we checked. So sub it in and show that it's 60. Cool. Okay, anybody got any questions? Everyone okay with why I bothered to do that sketch? Yeah, so if the graph had gone below the axis, the displacement and the distance would be different. So we do need to always check these things out, but this one's always positive. Good. All right, next one. Could you guys try this one? So we're now talking vertical Suvat. So we've got stuff being projected upwards. This says 7 marks. I think you guys can do this in 5 minutes. So could you please give this one a go? So 5 minutes on the clock. Can you do a Kahoot? I suppose we could. Maybe not today because I haven't got one ready, but I'll see if I can find a good one for Thursday. That could be fun, especially not in the same room. Those answers looking pretty good. What do you get for T? 6. I don't completely agree with that. Your U looks good though, but I don't know about T. So have another look, George. Looks like it's half right to me. Yeah, his U was good, but his T was not. So he got the right U, he got the wrong. It might be. Maybe I did it wrong. Yeah, maybe. We'll have a look in a sec. Cool. All right. Let's have a look at this one then. So, particle is projected vertically upwards, and yeah. So I'd always draw a sketch for these ones so you can get a rough idea of what's going on. So, point O, and 2 seconds later, it is still moving upwards. Cool. So for part A, U is 1/3. U is U, and V is U over 3, and A is minus 9.8. Cool. Right. So if we work this out, we can say we can do V equals U. Wait. 2 seconds later, T is 2. So V equals U plus AT. So U over 3 equals U minus 9.8 times 2. So let's get out the way again. If I add 2 times 9.8 to each side, 19.6 equals U take third U is going to be 2/3 U times by 3, and we end up with U equals 29.4. Cool. All right, to do the other bit then, to do part B, we know our total displacement. If we're going to go up and then come back down, total displacement vertically is going to be 0. So S equals 0, A equals minus 9.8, U equals 29.4. We want to find T, so 0 equals 29.4 T minus 4.9 T squared. So if we solve that quadratic, we should get T is 6.39 seconds. Cool. So I don't know why you guys got 6. What did you guys do? Did you try splitting up into 2 and maybe it went wrong? Or, I mean, I can double check that quadratic, but I think it's pretty right. Um, oh, it is 6. Weird. Okay, yeah, cool. Don't know what I did when I worked this out the other day. Cool. All right. Moving swiftly onwards. How many more of these we got? 3 questions left, and then we're done with Suvat. Cool. Okay, let's keep going then. So now we got another vertical question. We got one ball being thrown down, the other is being thrown up, and the balls collide. We want to find the distance of where they collide from the point where A was thrown. I think we might have done this one before, but I think I did it as an example before, so I would like you guys to try and solve this one yourselves. 5 marks. If you can do it in 5 minutes, that would be pretty impressive. So see if you can. So 5 minutes starting now. That's close. I make it slightly more than that, Joan. You're very close though. Yep, there you go. 29.6. Charlie, yours I think is measured from the floor and not from the top of the tower. So double check that. But yeah, Joan seems to be correct with that so far. Yeah, easily done. Good, glad to hear, Sophie. Cool. Right. So going through this one, we've got a tower, 46 meters. So A is thrown down with 5 meters per second. B is thrown up with speed 18 meters per second. So the trick to this one is kind of reconciling both those at the same time. All right, so we need basically two different equations for each one. For ball A, then we'll say S equals 5t plus 4.9 t squared. And because we're measuring it from the point ball A was thrown, we don't have to change anything for A. For ball B though, and this is where it gets difficult, the tower is 46 meters high. So if we want an expression where S means the same thing, we need to remember that S for ball A plus S for ball B should equal 46. So if this one's going to be S, our ball B displacement needs to be 46 minus S. Because you imagine ball B starts 46 meters away from the top. Every meter that ball B moves up is getting a meter closer to the top, so a meter less distant than 46. So we say 46 minus S equals, and we'll resolve upwards, 18t minus 4.9t squared because we've got gravity pulling it down. So I'm resolving one going down, the other one going up. And we just need to solve these together. So if I add together these equations, I'd get 23t equals 46. Therefore, t equals 2. And I can put t back in to either of my equations to get s equals 5 lots of 2 plus 4.9 lots of 2 squared. So s equals 29.6 meters as measured from the top of the tower. I can forget about. I mean, you don't really forget about it. I would keep it in there because it's part of the equation. They're both undergoing acceleration. What we're saying though is if we're saying one's falling down, the other's going up, the signs of the gravity are different. One of them is being slowed down, one is being sped up. Therefore, they cancel. But you ought to include them in your calculations. Otherwise, you're not really doing Suvat properly if that's the case. And yeah, we know that they will cancel because they're both falling at the same rate. Um, but you probably need to include it in your equations. Nice, Jen. Like it. Okay. Anybody got any questions about this one? Because it is pretty difficult compared to the others. No, everyone right? Cool. Right, moving on then. Almost done with Suvat. I know it's been a bit of pain, but Suvat's normally one of the more difficult concepts. We got this question about the bouncing. Um, yeah, so two more. One's bouncing balls, and then we'll do look at one where there's a time delay. So if you guys could try this one. So a ball is released from rest. It's going to bounce. Every time it bounces, it rebounds with less speed. Find the greatest height above the floor that the ball reaches. So 7 marks for this one, and I'll give you guys 7 minutes again, and then we'll go for it. Cheers. Anyone need any help so far? I'm not so sure about those. Let's have a look, John. Um, hmm. You are looking for the greatest height, yeah? Yeah, George, I agree with you. You are correct, George. Here's a klaxon. Um, yeah, Joan, I don't know what you're doing. You're definitely finding the displacement. Oh, your video, Caleb. Nice, Sophie. Good. Yeah, time. I guess if you put time into displacement, it might work. I don't know, because you're gonna have a different. Hmm. Try it. We'll see. Right, I'm gonna start getting this ready. So keep going, guys. I'm just gonna do some writing on the screen though. Cool. Right, so I've done a quick sketch at the top there, so you can see ball comes down, bounces, goes back up, velocity goes to zero, goes back down, bounces, goes back up, velocity goes to zero, goes back down. So we're looking for the displacement when the velocity is zero on both of these bounces. So I've started compiling my first Suvat equation. It starts at zero, s is 10, 9.8 is gravity. So we want to find what speed the ball hits the floor at here. We're then going to use that as our initial velocity, use v as our final velocity to work out this one, and then we'll start the whole process again. Right, so we're going to use v squared is u squared plus 2as. So v squared equals 0 plus 2 times 10 times 9.8. And if you solve that, you get v is 14 meters per second. So that's the speed it hits the ground at. But now we're told when it hits the ground, it rebounds with 3/4 of that speed. So our initial velocity for the kind of like the next region, this region here, our initial velocity is going to be 3/4 of 14. So we can start that over here. U is 3/4 14. V is 0. A is minus 9.8. And we want to find what s is. So v squared is u squared plus 2as. So 0 is 10.5 squared plus 2 minus 2, 9.8 times s. If you solve that, you get s is 5.625 meters. Cool. All right, so that's how far up we are at this point. So we're going to hit the ground at the same speed that we left the ground here. So our ball will hit the ground with a speed of 3/4 of 14. In other words, 10.5. And we're going to rebound with 3/4 of that speed. So for the next region, our initial velocity is 3/4 of 10.5. Again, final velocity is 0 and a is minus 9.8. So we're going to do the same thing again. We still want to find s. So this time we're going to get 0 equals 7.875 squared minus 2, 9.8 s, and we get s equals 3.164 meters. Cool, which a few of you guys, I think a couple of you got. Is that right? Yeah, George got it. Well done, George. Everybody else okay with that? I'm going to assume yes. So one more question on Suvat, and then we'll get on with some projectiles, which is much more interesting. So, last one. A stone is dropped from the top of a building, and 2 seconds later, another stone is thrown vertically downwards after it. So we've got top of the building, one stone is thrown down, and 2 seconds later, another stone is... Okay, one stone is dropped, the other stone is thrown, and those stones are going to hit each other. So we're trying to work out... Oh no, both stones reach the ground at the same time. So both stones collide at the bottom, and we're trying to work out how tall this building is. Cool. All right. Let's give you 4 minutes for this one. Let's really try and amp up the speed. So 4 minutes. Give it a go. Both things are moving in the same direction, so that's good. We've already done a time delay question, just not a vertical time delay question. So see if you can look back at the one we did earlier, figure out how you're going to pair these together, and see if you guys can solve this one. Cool. So 4 minutes starting from now. All right. Anyone need any help? So about a minute and a half left. Yeah, see how you get on. As a hint, it should be more than 150 meters tall. Cool, yeah, Caleb. Pretty close. I think. Yeah, cool. Right, let's whiz through this one and we'll start talking a little bit about projectiles. So if I number these 1 and 2, just so we can keep track on these. So 1 is our first stone that's dropped. So the first stone that's dropped travels the distance s, has an initial velocity u equals 0, a is 9.8, and t equals t. Cool. The second stone, s is just s, u is thrown down, so u is 25, a is 9.8, and t this time, well, this is 2 seconds later, so we need to do t take 2, because if the red one has been falling for 5 seconds, the blue one's only had 3 seconds to cover as much ground. So s equals ut plus half at squared. Just squashed it in there. So if we solve those two simultaneously, we get 4.9t squared equals 25t minus 50 plus 4.9t squared minus 19.6t plus 19.6. If we solve that, you get t is 5.7. Sub that back in, we get s is 155.3 meters. Cool. All right. Anybody got any difficulty still with kinematics? Because that's it. That's it covered. We've done as much revision as I can think of. Every kind of question we can do for kinematics. All right. Still got 15 minutes left today, so let's make a start on. Well, actually, shall we? I might leave it there because I don't want to start projectiles and then have it split. So I guess we weren't meant to have a lecture today anyway, so we can probably get away with it. So yeah, okay, that'll be it for today. Can you guys just make sure, I can see in the comment or in the group there's 11 of you. I've only got in the register, oh my god, 8 of you. So 3 of you haven't said your name. So who else am I missing? Yeah, they were all right. Really cool. Okay, anyone heard from Becca, Leo, Fifi, or I guess Charlie? I'll put you down. You were for most of it. But yeah, Fifi, Leo, and Rebecca. Are you guys out there? If not, can people remind them to watch this? Yeah, from tomorrow onwards, the college are tracking attendance, so you need to comment to let me know that you've watched this. If you're watching this afterwards, can you send me an email to show me that you've watched it all the way through? Send me an email with the number 42 in it, and I'll remember. Ah, okay, Sophie's too. Yep, that's fine. I know a few students do that, so you can watch and comment at the same time. Backhand. Oh, yeah, she did. She did say, I think. Okay. Anyway, yeah. Anybody got any questions? If you do, drop me an email. I think I'm going to do the workshop on Wednesday. So if you do want any help with any problems that you've got, email them to me by Wednesday, and then on Wednesday we can go through those. Yeah. Anything else people want to talk about? If not, tomorrow we'll be doing projectiles. I reckon we can get through most of it tomorrow. Yeah, good code. I agree. All right, cool. Cheers, guys. Thank you for tuning in, and I'll see you tomorrow. Bye.